Hi students, in this video we have to discuss about the Fourier series problems with the problem solutions. Right. The Fourier series. Fourier series is a periodic function occur frequently in engineering problems. Such periodic functions are often complicated and it is developed by the mathematician Joseph Fourier in 1768 to 1830. If f of x is a periodic function with period 2 pi and it's defined as c, c plus 2 pi and the Dirichlet conditions are satisfied, then f of x can be expanded as a Fourier series. This is the Fourier series formula. F of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. Here the values of a naught, an, bn are called the Fourier coefficients Fourier coefficients. By calculating using the Euler's formula, here a naught equal to 1 by pi the limit c to c plus 2 pi integral over f of x dx, and an means c equal to 1 by pi integral over c to c plus 2 pi f of x cos nx dx, and bn equal to 1 by pi integral over c to c plus 2 pi f of x sin nx dx. This is the Euler formula. We have to substitute the values of a naught, an, bn in the Fourier series formula. Right. These are some standard integrals. We have to integrate e power ax sin bx dx equal to e power ax divided by a square plus b square a sin bx minus b cos bx, and integral of e power ax cos bx dx equal to e power ax a square plus b square a cos bx plus b sin bx. And for formatting these formulas by using the Bernoulli, integral over uv dx equal to uv1, where uv is differentiation as u dash, u double dash, u triple dash. This is you have to differentiate, and this values v1, v2, v3 we have to integrate the given equation. As well as you know that the value of sin n pi is equal to 0 if n is an integer, and cos n pi equal to minus 1 power n if n is an integer. So you have to remember these trigonometric results to do the problem. Okay, right. Now we have to discuss about one example. Here given, obtain the Fourier series of the following function defined on the limit of 0, 2 pi. In the limit 0, 2 pi, or as the period of 2 pi. Here given f of x equal to, here separating the value, the limit points 0 to 2 pi as 0 to pi and pi to 2 pi. Here f of x values are given as x and pi. For f of x equal to x, we take the limit points as 0 to pi, and for f of x equal to pi, we take the limit points pi to 2 pi. Here step 1, right. First of all, we have to find what is the values of a naught, an and bn. What is the formula for a naught? 1 by pi integral over 0 to 2 pi. Here given limit is 0 to 2 pi. So we substitute 0 to 2 pi f of x dx. Here the limit point will be separated into two parts. One is 0 to pi and the second one is pi to 2 pi. So 1 by pi integral over 0 to pi f of x dx plus 1 by pi integral over pi to 2 pi f of x dx. Here the limit point 0 to pi, the f of x value is x. For the limit point pi to 2 pi, the f of x value is pi. Here pi is constant, so we have to differentiate only integrate only dx. Integration of dx means x. Here x integration is x square by 2. Substituting upper limit minus lower limit, we get the value of pi by 2 plus pi. So here taking the LCM, pi plus 2 pi divided by 2. So we get the value a naught equal to 3 pi by 2. And step 2. In the step 2, we have to find an. An means 1 by pi interval over 0 to 2 pi f of x cos nx dx. Here likewise we have to find the value of an. We have to separate the integral as 0 to pi and pi to 2 pi. The limit point is 0 to pi. The f of x value is x. So we substitute f of x as x cos nx dx. And in the second value we have to substitute f of x is pi. So pi cos nx. Here x cos integration of x cos nx, we have to use the Bernoulli formula uv dx. Here uv dx. So we have to substitute x. We have to differentiate x differentiation 1 and remaining part is 0. Here cos nx, integration of cos nx is sin nx divided by n, and sin nx means minus cos nx divided by n square. So we get the formula x sin nx minus 0 dot sin n into 0 minus of cos nx divided by n square with the limit point 0 to pi. Here in the second value is a direct substitution. Pi is constant, so pi cancel. What is the integration of cos n pi? Sin nx divided by n. So substituting upper limit 2 pi means sin n 2 pi minus sin n pi. The value of sin 2 n pi is 0 and sin n pi is 0. Here also sin n pi is 0, sin 0 is 0. So we have to find only the value of this one, minus cos nx divided by n square. Substituting pi in the value of x, we get cos nx, cos n pi. What is the value of cos n pi? Minus 1 power n. In the next step, right, this is given cos 0 and cos n pi. Cos n pi means minus 1 power n, cos 0 is 1. So the values are 1 by n square pi. Here 1 by pi. Here both common LCM is n square. So 1 by n square pi cos n pi minus 1. So an equal to minus 2 n square by pi, where n is odd. We have to substitute 1, 2, 3 in the value of n. Means we get the value of minus 2 by n square pi, and the remaining even terms is 0. This is the value of an. The same method we have to use to find bn. What is the bn formula? 1 by pi interval over 0 to 2 pi f of x sin nx dx. Here the limit point will be separated into 2. So 0 to pi and another one is pi to 2 pi. Here x sin x. In this interval over x sin x dx, we use the Bernoulli's equation, and in the right hand side sin nx, integration of sin nx is minus cos nx divided by n, and we have to substitute the upper limit minus lower limit. Finally we get the value of minus 1 by n minus 1 power n plus 0 minus 1 by n 1 minus 1 power n. So here we have to substitute the values in the formula, Fourier series formula. F of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. In that formula we have to substitute the values of a naught, an and bn. So this is one kind of example for the Fourier series first problem. Now we have to discuss about the second problem. Okay, I go some easy problem to understand. Right, here obtain all the Fourier coefficients. What are the Fourier coefficients? A naught, an and bn of f of x equal to k, where k is a constant, the periodicity being 2 pi. So the limit point is 0 to 2 pi. So what is the first one? Fourier coefficient a naught. So a naught equal to 1 by pi interval over c to c plus 2 pi f of x ds, as we already know. So in that point, limit point is 0 to 2 pi. What is the value of f of x? K into dx. So k is constant, taking outside from the integral, we get k by pi integral over dx. Integration of dx is x. So substituting the value, upper limit is 2 pi and lower limit is minus 0. So we get a naught equal to 2k. This is the first value. Second is an equal to 1 by pi integral over c to c plus 2 pi f of x cos nx dx. Here f of x is k. So k constant, taking over to outside by the integral k by pi integral over 0 to 2 pi cos nx dx. What is the integration of cos nx? Sin nx divided by n. Substituting upper limit minus lower limit in the value of x, we get sin 2n pi minus sin 0. Both the values are 0. So an value is 0. In step 3, we have to find bn. Bn means 1 by pi interval over c to c plus 2 pi f of x sin nx dx. So f of x value is k, taking outside. So integration of sin nx dx is minus cos nx divided by n. Here substituting upper limit minus lower limit in the x value, we get cos 2n pi minus cos 0 divided by n. What is the value of cos 2n pi? Is 1, and the cos 0 value is 1. So 1 minus 1 is 0. So again bn value is 0. Here the question is given is obtain all the Fourier coefficients. So just you have to find a0, an and bn. If here find Fourier series means you have to find f of x equal to a0 by 2 summation an cos nx plus bn sin nx. In that formula we substitute the values of a0, an, bn. Obviously the values of an, bn is 0. So we only get a0 by 2. So what is a0 by 2 means? a0 is k by 2k. So 2k by 2 means f of x equal to k. That is the solution for this problem. This one is very important. Even and odd functions. The function f of x is said to be even if f of minus x value is equal to f of x. And the function f of x is said to be odd if f of minus x equal to minus f of x. These two are very important conditions for even and odd functions. Now let us discuss another one example of a Fourier series. Here very important problem. Here expand in Fourier series. Expand in Fourier series of periodicity 2 pi. So what is the limit point? 0 to 2 pi. Here f of x given is x sin x for the interval 0 to 2 pi. So first step, here we have to find the Fourier series. So we remind the formula as f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. So a0 1 by pi interval over 0 to 2 pi f of x. Here substitute f of x value is x sin nx. In that step we have to integrate x sin x. So obviously we use the Bernoulli formula. So we get x minus cos x minus 1 into minus sin x. Substituting upper limit minus lower limit. Upper limit substitute means 2 minus 2 pi cos 2 pi minus plus 2 sin 2 pi. So the value is cos 2 pi is 1. So minus 2 pi, sin 2 pi is 0. So 1 by pi minus 2 pi. So we get the value a0 equal to minus 2. And again we have to find the value of an. So as usual x sin x cos nx dx. Here the term x sin x cos nx. So here we substitute the trigonometric formula cos a sin b is sin a plus b minus sin a minus b divided by 2. We use the formula sin a, once again I will tell, cos a sin b means sin a plus b minus sin a minus b divided by 2. So divided by 2 is taking over the limit point 1 by 2 pi interval 0 to 2 pi x sin n plus 1 a x minus sin n minus 1 into x. So here the two terms are given, x sin n plus 1 and x sin n minus 1. So again we use the Bernoulli's formula and substitute in that values by using 0 to 2 pi, upper limit is 2 pi and lower limit is 0. Substituting and cancelling the values, we get an equal to 1 by n square minus 1. We have provided if n not equal to 1. So if a1, substitute n equal to 1, so a1 equal to 1 by pi interval over 0 to 2 pi x sin x cos x dx. So 1 by 2 pi x sin 2x dx. Here sin a plus b sin a minus b. So 1 by 2 pi, here Bernoulli's equation, x into minus cos 2x by 2, that is u into v1. v1 means integration of sin 2x is minus cos 2x divided by 2. And again u dash, so x dash means 1 and again integration is minus sin 2x divided by 4. Substituting upper limit 2 pi and lower limit 0, we get the value a1 as minus 1 by 2. In step 3, where as usual write the formula bn equal to 1 by pi interval 0 to 2 pi f of x sin nx dx. Here f of x is x sin x. So 1 by 2 pi sin a sin b is cos a minus b divided by minus cos a plus b divided by 2. Here 2 taking outside, so 1 by 2 pi x cos n minus 1 x x cos n plus 1 x. Again using Bernoulli's equation, we get the value of bn 0 and if we substitute b1 value 1 by pi interval over 0 to 2 pi x sin x sin x. So sin x into sin x is x sin square x. What is the formula for sin square x? 1 minus cos 2x divided by 2. So multiplying x, so x minus x cos 2x by using Bernoulli's equation u v dash minus u dash v double dash. So substituting 2 pi as a upper limit and 0 as a lower limit, we get the value of 1 by pi into 2 pi square v1 equal to pi. Therefore, the Fourier series expansion of the function x sin x is given as f of x equal to, this is the formula, a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. So f of x is x sin x equal to a0. What is the value of a0 is? What is the value of a0? a0 is minus 2. So minus 2 divided by 2 is minus 1 minus 1 by 2 cos x plus 2 into summation of cos nx n square minus 1 plus pi into sin nx. So I hope so you will understand these three problems from the Fourier series of the interval 0, 2 pi. So in the next video we have to find the values at the interval of minus pi to plus pi. Thank you.